Hi guys, Larry here with Creaky Chair Models. This video is going to be about setting up an Arduino Mega 2560 as an input and output module for JMRI using the CMRI system created by Dr. Bruce Chubb. I'll go over the hardware here in a little bit of the things that I really think you should have in stock. This will be the first of about 4 videos, I believe. This one is just going to be setting up the Mega for inputs and outputs, and I'm going to cover the hardware and the software. The first thing you need is an Arduino Mega. These are readily available on eBay, AliExpress, even on Amazon for $1 or so more. The other thing that I'm showing here is 2 different shields that are called sensor shields. I like these because they make it simple to hook things up, and I'll go over that a little bit. And here's the other one. I'm going to take a minute and flip them over and show you why I like the one in yellow. If you notice the one in yellow, there is nothing over here as compared to here. You have more pins. These are the 5-volt and ground input pins, but over here there's nothing. So when you flip it over, you see that your power select is way over here, okay? Which equates to over here on the Mega. This one, you have pins here, and when you put that shield on, your input power can come in contact with this metal. So you need to put a piece of black electrical tape on it if you're going to use the blue ones. And I'll include links to both for Amazon. And it's not my Amazon, so I'm getting nothing for it. I'm just going to share links, okay? You can shop around and find them cheaper if you want to. But if you notice, the power select is here on this one, and it's over here on this one, so it avoids that potential short. These things quite simply just sit down on top, and with a little alignment, they fall right in place. The other thing you really need is a regulated power supply. I have a bench supply here, pardon the mess, right there. It's a regulated supply, and it's currently running another Arduino. That's why you have 40 milliamps of current draw. But I've got it set to 5 volts, and it will power this. Use caution if you use a cell phone supply, because some of the higher output current ones will actually be up near 6 volts and can cause damage to your Mega. So a good power supply is in order. A couple of ways you can go about it. You can use a little regulator like an LM2594, and I'll put a link into those. That'll keep it down and make it nice and stable. And or you can have a standalone supply like this, but be cautious. Make sure the voltage is truly at 5 volts. I'm going to pause here and come back. Okay, we're back. I have installed the shield on top of it, and you'll also see that there is a good deal of distance between this shield and the top of that USB port. The other thing you will need is a USB cable. I'm not going to go over the basics of Arduino. There are 100 videos out there on how to hook up an Arduino to a PC and use Linux, Mac OS, whatever, from Windows, and being able to program it. So we're going to kind of skip ahead in a couple minutes here, and you're going to be looking at the screen, and I will go over the code that I used for this. The one other thing that I did with my system is I have used RS485 so that I can daisy chain a bunch of modules on a single USB input. As it's presented today, you can plug a USB port in here, upload the code, and then you can plug in any sensor you want to. I've covered this in another one of my things, but if you look, you have an S pin down here, a V pin, and a G pin. G is ground, V is 5 volts, and S is the signal. And next to it is the pin number that it combines, that it correlates to. So all of the pins on the Mega are identified in these 3 rows, and then there's certain setup ones that are right here. Additionally, the I2C outputs and all that are identified. You also have a reset button, you have a receive data light over here, and a power light up here. So that pretty much covers the hardware. That's about all you really need to do other than plug the USB port in and get ready to program. If you want to hook up a sensor, what I do, and I've covered this on another video, but I'll drag out a sensor here and show you. I took a servo connector and I soldered it onto this little UV sensor here. It's got a transmitter and receiver. Signal lines here, ground lines here, B plus is here. You'll notice that that's not the same order they are on here. So pay attention when you hook it up. Just use the red for voltage and ground, black and white for signal, and you'll be okay. These cables are, this is a 1 meter one that I've cut back, and it's they're about 89 cents or something if you buy 10 or 12 of them on Amazon. So for breadboarding, I build these up and I use these for testing. Additionally, I'll take one of these ends and I'll cut it off and I'll solder a bipolar LED with a resistor to it. So one last thing that I will go over. There's been some concerns that people have said you only have 200 milliamps of current draw. All right, so I took a 590 ohm resistor and put it on a bipolar LED. Current draw measured at the output pin was 7 milliamps. Okay? The actual published output on this, I think, is actually closer to 300 milliamps maximum. Do the math. Okay? And if you're using sensors, there's almost a 0 current draw on the signal pin. So you can drive a whole lot of LEDs with one of these. Now on the Uno or the Nano or the Pro Mini, you are limited to 200 milliamps, but you only have 17 outputs. Do the math. At 8 milliamps, you're taught with everything running, you're under 150 milliamps. So you're perfectly safe. And that's using every output. And they can be, you'll see in the software, this can be configured any way you want. Additionally, the code will be available. Just message me on Facebook or just reach out to me at creakychairmodels.com. All my contact information's there, and I'll be happy to give you a link to the code, or you can create your own. All right, so we're going to step on over to the PC now and begin our work there. So obviously the quality of the audio will change because I'll be on a better microphone. Thanks. See you in a few minutes. Okay, guys. We're here at the Arduino screen, and I'm going to kind of step through the code real quick and explain some things that are going on. Got it pretty well documented here. It's combined sensor inputs and other outputs. Pins 0, 1, and 2 are protected. We use those for the RS485. Pin 13 is the Arduino LED pin, and you should not use it as an input unless you cut the trace on it to eliminate that LED, because the input will not work well. Alright, we set it up to behave like a piece of CMRI headwork called an SUSIC. We will go through that in JMRI. And there's some other notes here. It's we can make it more efficient by not overloading the SUSIC, but we can go through that as we get to it. We'll set card 0 and 1 to be sensor inputs and 2 to 5 to support 128 outputs. Actually, that's not correct. Yes, 0 and 1 are sensor inputs on mine, and I'll show you that too. These are the libraries we should include. Wire.h, and you'll have to download CMRI.h. I will put a link in the show notes to where to download this. The other one is Auto 485. This is for the RS485 communications. These are your CMRI settings. We're doing declarations here. So we're defining it as CMRI address 1. That makes it node 1 beginning in JMRI. You'll find that the outputs and inputs start at 1000 as their number. This DE pin 2 is part of the Auto 485. Next thing we're doing is we're setting up the Auto 485 bus, again, pin 2. Here's where we're going to define the CMRI connection with 64 inputs and 128 outputs. Right here is the inputs and the outputs, and the bus tells it, if available, to use the 485. Okay, here's the setup. First things we have to do is we have to define whether a pin is an input or an output. And we have a little for loop that says for I equals 3 to less than 20, in other words 3 to 20, increase it, and then set the pin mode to I as input pull-up. For those of you who don't know what input pull-up is, it puts in a resistor so that you do not have to physically put in a 100K resistor to pull the pin up to a high. It's built into the Arduino. It works perfectly. Down here we have 22 to 70. Remember, less than 21. Okay, I left 21 and 20 open for a reason. They work fine. I left them there should you decide you want to do some I2C work. Those are the pins for it. Pin mode 13 I defined as an output. All right, the next thing we're going to do is set the Serialbaud rate. I set this to 19.2, which is the default. Again, you have to make sure this matches in JMRI or it will not begin to communicate. This is critically important. You can bump this, and I tested it. I bumped it up to 28 and it worked fine. So I have not tried any of the higher ones just because of the amount of time it takes to set up the number of sensors to see if it would be valid. This will be nice and safe. All right, so here's our void loop. Okay, we're going to tell it CMRI process. So it says whatever happens after that we're doing. So here's what we're doing. We're not reading 0, 1, and 2. The first thing we're doing is we're reading digital 3. And if you scroll down, you'll see that we get down to digital 19. And it sets a CMRI bit of 0 through 15. So these are your inputs. And in the notes here, you'll see that the addresses start at 1001 for an input and 1016 for an input. So you have obviously 16 inputs, my apologies. But you notice we skipped bit 13 skips right here. I'm sorry, pin 13. 9 goes from 12 and it skips 13 and goes to 14. If you want to increase the number of inputs, let's say you wanted this entire thing to be an input card with 69 inputs, then what you would do is you just create a line for each one of these and digital read that pin. But you have to go back up here and set this I level to skip 20 and 21, which we did there. So you would just do another pin mode input pull up and make it as high as you want. And obviously you would have to decrease the outputs. It's the same thing. If you only want 5 inputs on it, you can make all the rest of them outputs. It's entirely up to you, but you have to make the changes here and you have to add the lines here. Guys, I know I could have done a couple of variables and set the variable to to make this one work and change this one to increase and then skip from there. I like the individual lines. It keeps my sanity for a quick reference when I go back. So that's the inputs, okay? Next thing we're going to do is we're going to process the outputs. So what we're doing is these are non-servo outputs. They start at bit 100, so it's 1101 in CMRI, okay? So I didn't put the comments in for each individual pin here, and I may do that sometime in the near future in the code. But you can see, you're going to tell it to digital write pin 22, the bit from CMRI. JMRI tells CMRI to turn an output on or off via 0, 1, 2, all the way on up. You'll see that we ended at 48 here, which is pin 70. Okay? The ending address is 1148. That's a typo there. It should be, nope, I'm wrong. It's 1048 and 1001. Okay? That's the entirety of the code. So you can take these pins down, but remember, your bits have to start at 0. So if you decrease the number of outputs and say you only had 5, then this would be 0 and this one would be 5. And all the rest of those would change because those bits would be assigned to the inputs. And exactly the opposite, if you wanted fewer inputs and more outputs, you would start at your output pin at 0 and then you would have a higher number. It's relatively simple. It sounds complicated, but you just have to think of your thought process and you'll be just fine. And really, after that, you just upload it to the Arduino. You know, the other thing you have to do is, I've got this setup hooked up to a Nano, but you have to make sure you have an Arduino Uno selected, the correct serial port selected, and away it goes. After you've done that, your Arduino is programmed and ready to go. The next step will be for us to go into JMRI and do some setups. So we'll pause here and we'll step into the next section. Okay guys, I'm here at a bare JMRI screen and I'm going to walk you through some very important things and configuring CMRI and JMRI to make it work right within the Arduino Mega 2560. First thing we're going to do is I'm going to go to Add Preferences. Alright, if you have previously set up JMRI, you will have a connection here. In this case, this is a bare bones one and you will not see any connection. So we're going to create one. Okay, we're going to do system type or manufacturer, and it's going to be C/MRI. We'll use serial, and we'll come down here and select the serial port, which is COM8. I know that because that's what I uploaded the code inside of Arduino IDE. Come down here, make sure, click your additional connection settings and make sure it's set to 19.2. If you changed it to 28.8 in the Arduino code, just come down here and change it. I'm leaving it at 19.2. Okay? We cannot configure the nodes at this point. We will have to restart. But there's some other things we can do. This is the most critical thing you can do. I cannot stress this enough. Right here we need to click add a pause, and it needs to be 8 seconds or more. 8 seconds seems to be the magic number. The reason we add this pause in there is we want the JMRI system sends a reset to the Arduino Mega. The Mega takes a minute to go through its reset because we added all of those inputs and outputs, and that takes a little bit of time. 4 seconds is probably enough. 8 works great. I have not had any issues with 8 seconds. I err on the side of caution. Feel free to experiment shortening it. you'll know because your sensors won't work, and I will show you how to tell whether it's communicating or not. Okay? So the next thing we want to add is we want to add a button to the main window. And this button, when you're using Decoder Pro, helps you see the sensor tables and all of the tables. And if you do that, it's called Open Tables, okay? And you do OK. So now we're going to do Save, and it should come up and ask us to restart. And I'm going to restart it, and we'll be back in a minute when this thing is done with its restart. First thing we have to do is we have to add a CMRI node. So we have to configure CMRI. You do that here at Startup, again, but you do Connections. Under CMRI, you do Configure Nodes. Add a node, and if you remember from the first part of the video, it was address node was 1, and the node type was SUSIC, which is this one, USIC underscore SUSIC. Okay? The card size, change it to 32-bit. And now you're going to come down, and remember in the Arduino we said it had 2 input cards followed by 5 output cards, 4 output cards. So we're going to come down and make these all output cards. And then we're going to do, make sure enable polling at startup is on. We're going to do add node and done. And here it's telling us, remember to save it by the save button in the preference window so it automatically comes up. And here we're going to do done. So now, since we've done all that, we can now save one more time. See here in a minute. Every now and then I've had this where I click save and it came back to this screen. If it does that, just click the red X and it'll ask you, do you want to save them, and do yes. And when we come back, we'll get into the next steps. Okay guys, I should have told you that when you do it that way, you have to manually restart JMRI. If you look at the camera, you'll see I have a sensor hooked up to pin 4, and I have an LED hooked up to pin 22, which is the first input. I have the negative going to a 1K resistor, and the signal output going to the positive lead on the LED. So now we're going to go ahead and we're going to configure our sensors and our output light. So we're going to click on the listed table access. I'm going to move this down because I believe that the camera is in the way. So the first thing we want to do is add our sensors. I'm going to show you how to add 3, and then I'll show you that they work. So you click on sensors, it should change over. If it doesn't, just go to view sensors and it'll change over. And just to keep it simple so it doesn't make a mistake and you don't automatically inherently change the type of sensor, I just click on CMRI. That way when I do add, I can do 1001. Remember, that was our address starting. And then I can call it pin 3. Okay, create. You cannot sequentially add them. It shows up, but it'll barf every time. So I just do 1002, change it, pin 4, create, add one more, 1003, pin 5. So if I did this right, I've got a sensor hooked up here. All 3 of them are showing inactive. But if I cover this sensor, it should go active. And look at that, it did. 1001 went active. Okay, and that's actually on pin 4. I'm going to have to look. I may have made a mistake in the code. But the corrected code will be out there. But at this point, it works. All right, so let's add a light. So we clicked over to the lights. We're going to do CMRI again, and we're going to do add. And we know pin 22 is address 1001. And then we're going to do pin 22. That's just a good reminder for us. And I'm going to create it. So if you notice, if I click this on, you should see on the camera that the LED comes on and goes off, comes on and goes off. So I'll show you a little bit more of what we can do here. And what I've had a great deal of fun playing with is if you go to Edit, and then you come over here to Light Controllers and do Add a Controller, you have a lot of options here. Let me pull this down a little bit. The controller type is you have by sensor, or by fast clock, by a turnout status. So if you throw or close a turnout, you can turn the lights on and off, or you can turn it by a timed on. So if you do that timed on, you can do a bunch of sequences, or you can have it work off of 2 sensors. This one, just for a quick experiment, we're going to do by 1 sensor. We're going to come down and choose pin 3 because that's the one that was turning on earlier. So now if I create that, you'll see that it created a controller here. And you can stack a bunch of these so that various things can turn them on. Okay? So now we need to do apply and OK. So if I did it right, when I cover this sensor, this LED should come on. Now I'm not really covering it, it's reflecting off my hand. But as you can see, up here on the screen, the state of the light went on. If you come over to the sensors page, stick with me guys, I'm doing this left-handed. You'll see that the sensor on pin 3 went active. Take it off, light goes off, on. And you can do that for any of these. And you, as I said, you can stack the requirements for turning the LED on. As a dispatcher, if you have these out as signals on your layout, you can actually set up a panel. There's a CTC emulator for JMRI, one of the guys created, and you can create a virtual CTC panel and turn the signals on manually. If you want them to be automatic, you can put sensors in. Any kind of sensor can feed the Arduino, remember. As long as it's 5 volts, actually 3 volts will work. Low to high, you can configure it, and you've now got your full interface into JMRI. All right, this is the first of about 4 to 5 videos. Don't hold me to the number because I don't want to waste your time. But I have another node over here that is an Arduino Nano that will control up to 64 servos using a little board called a PCA 9685. I have another one I'm working on using an Arduino Nano that will control 12 servos, and you can vary the speed and the amount of throw individually on them in the code. It's a little harder with the PCA 9685, but it can be done. And I have another Nano that I've configured, and it's right over here. And it is currently set up with 4 signals towers, red, green, yellow, and it automatically works off 4 sensors, so it goes through the proper color combinations. And I have another one that's a Nano that has however many sensors or outputs you want on it. So you're not locked into spending $16 on this. You can buy the Nano, and I think with the Shield, it's probably closer to $20. With the Nano, you can still go through all this process, and the Nano Shields are a lot cheaper. I want to say you're in the neighborhood of $6 each. Yeah, you have more pins on this, but if you're doing nodes around your layout, the Nano may fit in a place better than the Mega does. I know this was a long video. I appreciate your patience with me, and I'll turn the light on one more time. Oh, one last thing that I'm going to show you on the screen is you need to go up. You need to do on the sensor window, which let me get back there. You need to File, Store. If you have panels, do Store All Table Contents and Panels. In this case, all we have is tables. I've created a file here called Test, and you store it. Okay? So now that you've stored that, you go back into Preferences. See, I thought I was done. I wasn't. And you do on Startup, you do Add, Open File, and then here your test file opens there. You do Open, and then you do Save. Next time you restart, everything will be in there, and all of your configuration will work just as smoothly. When you cover the sensor, the light will come on and all. Hey guys, thanks again. Have a great day.